What if the reason you feel less energetic, less sharp, and slower to recover than you did 15 years ago has nothing to do with willpower, fitness, or even the foods you are eating, and everything to do with a single molecule your cells are quietly running out of? Not a hormone, not a vitamin, a cofactor, a helper molecule. One so fundamental to cellular energy production that without it, your mitochondria simply cannot do their job, no matter how healthy your lifestyle appears on the surface. I am Dr. Ava Collins, and this is the Eternal Vigor Way, where we take the science that belongs in your hands and actually put it there. Today we are talking about NAD+, nicotinamide adenine dinucleotide. And I want to be precise with you from the very beginning, because this topic has attracted a lot of hype, and hype is not something I deal in. What I deal in is what the peer-reviewed evidence actually says, including where it is strong, where it is still developing, and where the popular conversation has gotten ahead of the data. Stay with me through the full video. I have structured it deliberately. The most important nuance, the one that most content on this topic gets completely wrong, comes closer to the end. I want you to have the foundation first. Let us get into it. Let us start with the biology in plain language. NAD+ is a coenzyme, which means it is a helper molecule that enzymes require in order to function. It is not a fuel source itself. Think of it less like gasoline and more like the ignition system. Without it, the engine does not start, regardless of how much fuel is in the tank. Specifically, NAD+ plays an essential role in a process called cellular respiration, the chain of chemical reactions inside your mitochondria that converts nutrients from food into ATP, which is the actual energy currency your cells use. NAD+ acts as an electron carrier in this process. It picks up electrons at one stage, transfers them, and enables the energy conversion to proceed. Beyond energy production, NAD+ also serves as a substrate, a raw material, for a class of proteins called sirtuins and another called PARPs, both of which are involved in DNA repair, gene expression regulation, and cellular stress responses. So its role in the cell is broad and foundational, not narrow, both of which are involved in DNA repair, gene expression regulation, and cellular stress responses. So its role in the cell is broad and foundational, not narrow. Now here is the central problem. NAD+ levels decline with age. This is one of the most consistently replicated findings in aging biology. Studies in both animal models and human tissue have shown that NAD+ concentrations in multiple organ systems, including muscle, brain, liver, and skin, decrease significantly as we get older. Some research estimates that by the time a person reaches their 60s, NAD+ levels may be roughly half of what they were in early adulthood. What drives this decline? That is where it gets interesting, and where the picture is more complex than most popular explanations acknowledge. One of the key drivers is an enzyme most people have never heard of. It does not just consume NAD+, it consumes it at a rate that accelerates with age. And understanding why that happens changes everything about how you approach this. We are going to get there shortly. Section 3, CD38, the enzyme consuming your NAD+. The enzyme is called CD38, and I want to be careful here because CD38 is not a villain. It is a normal part of your immune system's machinery. It has legitimate biological functions. It is involved in immune cell signaling and calcium regulation. The issue is not that it exists. The issue is what happens to its activity level as we age. Research published in the journal Cell Metabolism demonstrated that aged tissues show significantly elevated CD38 expression compared to younger tissues. And because CD38 is an NAdase, meaning it breaks down NAD+ as part of its function, higher CD38 activity translates directly into faster NAD+ depletion. Importantly, the research also pointed to a connection between CD38 elevation and chronic low-grade inflammation, which is extremely common in older adults. In this model, aging-associated inflammation drives up CD38, which accelerates NAD+ consumption, which impairs cellular energy and repair processes, which may worsen the inflammatory environment, a feedback loop rather than a simple linear decline. I want to be transparent about what this means for intervention. In animal models, inhibiting CD38 did result in NAD+ recovery and measurable improvements in metabolic function. That is a promising finding. However, deliberately inhibiting an immune-related enzyme in humans is not something we approach casually, and the therapeutic application of CD38 inhibition in healthy aging is still an active area of research. The animal data is not a direct prescription for human use. What this science does tell us is that the decline in NAD+ is not simply a passive inevitability of getting older. There are specific identifiable mechanisms driving it, and where there are mechanisms, there are potential points of intervention. One of those intervention points is nutritional. There is a flavonoid, a plant compound found in ordinary foods that has shown meaningful CD38 inhibiting activity in laboratory research. It is not a supplement, it is food. We are going to cover it shortly. But first, I want to address the question of whether you can actually raise NAD+ levels through supplementation, because the answer is more nuanced than the marketing would have you believe. The two most studied NAD+ precursor supplements are NR, nicotinamide riboside, and NMN, nicotinamide mononucleotide. Both are compounds that the body can convert into NAD+ through its internal biosynthetic pathways. The two most studied NAD+ precursor supplements are NR, nicotinamide riboside, and NMN, nicotinamide mononucleotide. Both are compounds that the body can convert into NAD+ through its internal biosynthetic pathways. Here is what the evidence shows, stated accurately. Multiple clinical trials in humans have demonstrated that both NR and NMN supplementation can measurably raise NAD+ levels in the blood and in certain tissues. A clinical trial published in Nature Communications showed that NR supplementation increased whole blood NAD+ levels in older adults in a dose-dependent manner. Similar findings have been reported for NMN. What has not yet been conclusively demonstrated in human trials is whether raising NAD+ levels through supplementation translates into the broad health outcomes, improved cognition, significantly better metabolic function, meaningful reversal of aging markers that the animal research has suggested. Meaningful reversal of aging markers that the animal research has suggested. Some human trials have shown encouraging signals in specific outcomes like muscle function and insulin sensitivity. Others have been more modest in their findings. What I want you to take from this is a calibrated view. The supplementation does appear to raise NAD+ levels in humans, and that is meaningful. But it is not a standalone solution, and it is not magic. It is one input into a system that has many variables. If you are considering NMN or NR, doses used in published human trials have generally ranged from 250 to 500 milligrams daily for NMN, and similar ranges for NR. Both have shown acceptable safety profiles in trials conducted to date. As always, discuss with your physician, especially if you are on medications. Before I continue, if this kind of honest, evidence-grounded health science is what you are looking for, please subscribe to the Eternal Vigor Way right now and turn on your notifications. Every week, we bring you this level of depth and accuracy on topics that directly affect how you age, how you feel, and how long your body functions at its best. This is the kind of information that takes real time to find and evaluate, and we do that work so you do not have to. This is the kind of information that takes real time to find and evaluate, and we do that work so you do not have to. Hit subscribe. It takes 1 second, and it means you never miss an episode. Now, let us talk about what you can do starting tonight with food. Research published in Nature Metabolism identified Apigenin as one of the more potent natural inhibitors of CD38 activity studied to date. By moderating CD38, Apigenin may help slow the rate at which NAD+ is consumed, complementing the body's own synthesis efforts. I am being deliberate with my language here. This is laboratory and early mechanistic research. It is not a proven therapeutic protocol, but the logic is sound, the compound is safe, the foods that contain it are nutritious for many other reasons, and the risk of eating more parsley is essentially zero. 2 to 3 tablespoons of fresh parsley daily is a practical amount consistent with research-level concentrations. Chamomile tea is another accessible source, with the additional benefit of documented effects on sleep quality. Quercetin, found in red onions, capers, and apple skins, is a second flavonoid with CD38 inhibiting properties, as well as an emerging body of research around senolytic activity. Quercetin, found in red onions, capers, and apple skins, is a second flavonoid with CD38 inhibiting properties, as well as an emerging body of research around senolytic activity, meaning the clearance of damaged senescent cells. Including these foods regularly is a reasonable, evidence-informed dietary strategy. It is not about what time you go to sleep, and understanding the distinction matters considerably more than most people realize. Your circadian system and your NAD+ metabolism are molecularly connected. The enzyme NAMPT, which is the rate-limiting enzyme in the primary NAD+ biosynthesis pathway, is regulated in part by circadian clock genes. Its activity follows a rhythmic pattern tied to the sleep-wake cycle. Research in animal models has shown that disruption of circadian rhythm leads to decreased NAMPT expression and measurable drops in NAD+ levels. That is an important mechanistic finding. But here is where I want to correct something you will often hear stated too simply. The critical factor for sleep's relationship to metabolic health and circadian biology is not the specific clock time at which you fall asleep. What the research consistently points to as most important is regularity, going to sleep and waking at consistent times, and total sleep duration, getting sufficient hours, generally 7 to 9 for most adults. A large epidemiological study published in Sleep found that irregular sleep timing was independently associated with worse metabolic outcomes, even when total sleep hours were adequate. Conversely, people with consistent sleep schedules showed better metabolic markers regardless of whether that schedule was early or late. This is an important nuance. The biology is not judging whether you sleep at 10 or at midnight. It is responding to consistency and duration. An irregular sleeper who goes to bed at 10 some nights and 2 in the morning on others is likely doing more circadian disruption than someone who consistently goes to bed at midnight every single night. So the practical guidance here is, find a sleep window that you can maintain consistently 7 days a week, protect it, and prioritize achieving sufficient total hours within it. Darkness during sleep, limiting bright screen exposure before bed, and morning light, exposure to anchor your circadian rhythm are all reasonable supporting strategies. Darkness during sleep, limiting bright screen exposure before bed, and morning light exposure to anchor your circadian rhythm are all reasonable supporting strategies, but they work best in the context of a consistent schedule, not as replacements for one. Now we get to the piece I told you was coming, the piece that I think reframes the entire conversation. Exercise is one of the most well-documented ways to upregulate NAMPT activity, the enzyme that drives NAD+ synthesis. When you subject your body to the controlled stress of vigorous physical activity, particularly resistance training and high-intensity interval work, you create transient cellular stress that triggers an adaptive response. Part of that response involves increased NAMPT expression. A study published in Cell Metabolism found that older adults undergoing high-intensity interval training showed gene expression changes in NAD+ biosynthesis pathways and improvements in mitochondrial capacity that exceeded those seen in moderate resistance training or combined training groups. This is strong evidence. Exercise works mechanistically on the NAD+ system. Here's the part most people miss. That upregulation happens primarily during the recovery period, in the hours and days following the exercise stimulus, not during the workout itself. The workout is the signal. The biology happens afterward. And this means that what you do in the recovery window is not secondary to your exercise. It is where the actual benefit is realized or lost. Poor sleep after training suppresses the repair response. Chronic stress, which we will address in a moment, impairs the signaling pathways that exercise activates. Nutritional deficiencies remove the raw materials the process requires. For older adults, whose cellular repair mechanisms are already operating more slowly than they did decades ago, this recovery window is not an afterthought. It is the intervention itself. The implication is significant. An optimized recovery environment, consistent sleep, anti-inflammatory nutrition, stress management may produce more meaningful NAD+ pathway benefit than adding more exercise volume without addressing those variables. I want to briefly address the relationship between chronic psychological stress and NAD+, because it is real, but it is not simple, and I will not pretend otherwise. We know that chronic stress activates PARP enzymes, the DNA repair proteins that consume NAD+ as a substrate. Sustained psychological stress is also associated with elevated inflammatory signaling, which, as we discussed, connects to CD38 activity, the DNA repair proteins that consume NAD+ as a substrate. Sustained psychological stress is also associated with elevated inflammatory signaling, which, as we discussed, connects to CD38 activity. So there are plausible mechanistic pathways by which chronic stress contributes to NAD+ depletion over time. What I cannot tell you with precision is exactly how large that effect is in humans, under what conditions it becomes clinically significant, or whether stress reduction interventions produce measurable NAD+ recovery. That research has not been done at the level of rigor required to make confident claims. What I can tell you is that chronic psychological stress has well-documented negative effects on sleep quality, inflammatory markers, metabolic function, and health outcomes across nearly every system studied. The relationship with NAD+ is one more reason, among many, to take stress management seriously. What I can tell you is that chronic psychological stress has well-documented negative effects on sleep quality, inflammatory markers, metabolic function, and health outcomes across nearly every system studied. The relationship with NAD+ is one more reason, among many, to take stress management seriously as a biological priority, not just a quality of life concern. Whether your approach is breathwork, physical activity, social connection, therapy, or simply protecting your sleep, these are not soft suggestions. They are physiologically grounded interventions. Before I close, if you found this video genuinely useful, and especially if you appreciate that I told you where the evidence is strong and where it is still developing, rather than just telling you what sounds most exciting, this channel is for you. Subscribe to the Eternal Vigor Way right now, and share this video with someone in your life who deserves this level of honest health information. The algorithm rarely finds the people who need this most on its own. You can help change that. Subscribe, share, and I will see you in the next episode. You can help change that. Subscribe, share, and I will see you in the next episode. Here is what I want you to walk away with. NAD+ is a genuinely important cofactor in cellular energy production, and its decline with age is real, replicated, and meaningful. The mechanisms driving that decline, including CD38 activity and its connection to aging-associated inflammation, are increasingly well understood. And the evidence that NAD+ levels can be raised through precursor supplementation in humans is legitimate, even if the downstream health outcomes of that elevation are still being established. The most evidence-supported things you can do right now: eat more flavonoid-rich foods, protect the regularity and duration of your sleep, exercise with the recovery window in mind, and take your stress load seriously as a physiological variable, not just a mental one. None of this is a cure. All of it is grounded in real science, and all of it is within your control. I am Dr. Ava Collins. This is the Eternal Vigor Way. In the next video, we are going to look at the gut-mitochondria connection, why the integrity of your intestinal lining may be one of the most underappreciated factors in how much cellular energy you have available as you age. It is a conversation that connects nutrition, immunity, and metabolic function in ways that will genuinely change how you think about digestive health. Why the integrity of your intestinal lining may be one of the most underappreciated factors in how much cellular energy you have available as you age. It is a conversation that connects nutrition, immunity, and metabolic function in ways that will genuinely change how you think about digestive health. Make sure you are subscribed so you do not miss it. I will see you there.